students, how are you? Hope you are fine. In my last content, though I have tried to make the content easily understandable for you, but still some of you has some problem in understanding, especially in Kirchoffs Law. So that's why today I am again taking the class and also show one math. That math will help you to understand more. Kirchoffs law, it has two parts, Kirchoffs current law and Kirchoffs voltage law. Kirchoffs current law, in short form, it is written as KCL, and also you can tell junction law. It can be told as junction law. So Kirchoffs current law or Kirchoffs junction law, it states that the summation of current in a junction is 0. That means summation of current I equal to 0. So Kirchoff's first law, that means junction law, it states that the total incoming current equal to outgoing current. The current which is entering into the junction equal to the current in leaving the junction. Look here, O is the junction. Junction means where two or more wire connects. So here we can see I1, I2, I3, I4 are connected with this junction O. So here we can see by the direction I1 is entering into the junction, I2 is entering into the junction, I3 is leaving, I4 is leaving, whereas I5 is entering into the junction. So I wrote here incoming current equal to outgoing current. That means I1 plus I2 plus I5 equal to outgoing is I3 plus I4. So we can write it in this way also, I1 plus I2 plus I5 minus I3 minus I4 equal to 0. So for calculation, for simplicity of the calculation, you can take which currents are entering into the junction, those you will take positive, and the current which are leaving the junction you will take those as negative. Okay, so this equation also can be written as in this way, I1 plus I2 plus I5 plus minus I3 plus minus I4 equal to 0. That means what? Summation of I equal to 0. That I have told at first, that Kirchoff's current law means the summation of current at the junction is 0. That means suppose 10 ampere current is passing through any wire or any conductor, and then in this point, at this point the current is divided into 3 equal parts. So through these wire 10 by 3 ampere, these wire 10 by 3 ampere, these wire 10 by 3 ampere. That means these 3 together is what? 10 ampere. So what you get? The incoming current equal to outgoing current. This is 10 ampere is the incoming current, and these are the at this point the current is divided into 3 parts, but those equal to 10 ampere. So the incoming current equal to outgoing current. If the incoming current is 60 ampere, then the outgoing current is also 60 ampere. It is not like that 20 ampere is incoming current, but after some time it becomes 30 ampere. It cannot be possible. That means what will be the incoming current? That will be the outgoing current. So Kirchoff's so I think from this example you can understand. So Kirchoff's, you have to remember one thing, Kirchoff's current law, it is following conservation of charge. Conservation of charge means what? Charge is neither created nor destroyed, only transfers from one body to another body. Current is produced due to the motion of the charge. We cannot produce the charge. The whole charge in the universe is conserved. Okay, from class 9-10 concept, that when two bodies are rubbing together, then charge from one body transferred to another body. Okay, when you comb your hair with a comb, then what happens? The electron from your here goes to the comb. So in this way charge transfers from one body to another body, but it doesn't create it or destroy it. Like that, the incoming current equal to outgoing current. That means it supports conservation of charge. So look, suppose if I current is flowing, but you can also think I1 current is flowing through the conductor, and at this point the current is divided into two parts, I2 and another one you think that is X. Okay, so I1 is the incoming current and I2 and X is the outgoing current. That means you can write I1 equal to I2 plus X. So X will be I1 minus I2. So KCL, that means Kirchoff's current law, is applicable only for the junction. You have to remember this. These type of questions can come into your MCQ. Okay, so you must remember these things. So in this way, by applying Kirchoff's current law, we can solve the circuit. You can ask me, why will we use this Kirchoff's law? Because in Ohm's law, when you solve the circuit by using Ohm's law, that time those circuits were simple. There is only one cell. But in case of Kirchoff's law, when you apply Kirchoff's law in those circuits where there is two or more cells are connected in the circuit, so the circuits are critical or complex. That's why to solve the circuit, Kirchoff's law is needed. Now, Kirchoff's voltage law, that is known as KVL. Kirchoff's voltage law, that is KVL. Also you can tell as loop law. KVL or loop law you can tell. So the algebraic sum of the changes in potential around any closed loop involving the resistor and cells in the loop is 0. In KCL you got summation of I equal to 0, and in KVL summation of del V. Summation of del V equal to 0. That means potential difference. Okay, the sum total of potential difference to all the resistor and the cell is 0. So in KVL you have to remember 4 points. For applying KVL you have to remember 4 points. Dear students, follow my class very carefully because Kirchoff's law is very much important in HSC examination. This by using Kirchoff's law, circuits should be solved. That's why you give your attention. So KVL, at first I draw the figure, then I will explain. Look, this is the cell's positive side and this is negative side. It is negative, it is positive. If you are trying to move in the circuit in this direction, along this direction, that means from positive to negative. So while going from positive to negative direction, you see the positive sign at first. The sign of the cell which you see at first, that will be positive. So the potential difference of the cell will be plus V. But if you are going in this direction, that means from negative to positive, which sign of the cell you are seeing at first? Negative sign. So the potential difference will be minus V. Okay. Now the current is moving towards this direction, and also you are moving to measure the potential drop along the direction of the current. Then that will be the potential difference will be positive. And if you are moving in this direction to measure the potential drop or potential gain in the resistor, then the potential difference will be negative, minus IR. So if you remember these 4 points, you can solve the circuit very easily. Now I will show you a circuit how to solve it. I have already told you that KVL, that means Kirchoffs voltage law, or you can tell loop law, that is applicable only for the closed loop. This I have already told you this type of MCQ come, that KCL applicable for the junction and KVL applicable for the closed loop. So look, in this circuit there are two loops. Okay, this is suppose this is loop 1 and that is loop 2. So A, B, C, D, A, it is loop 1, and E, F, B, A, E, that means from where you start, again you reach that point. From where you start, you reach that point. So these two are the loop. So in these two loops, I can apply KVL, that means Kirchoffs voltage law. So here I1 current is flowing through the to this direction, and at this junction or node I1 is divided into two parts. I2 is going towards that direction and I3 is going towards this direction. So now suppose I will start from point A. I will start from point A to measure the potential difference. Okay, so here if I am going to this direction, current is going this direction, but I am going to measure the potential difference against the current direction. So the potential drop here will be what? Negative, because you are moving against the direction of the current. So here through this R1 and R2, what amount of current is passing? I1. So the potential difference at R2 will be I1 R2. The potential difference at R1 will be I1 R1. But both will be what? Negative, because it goes against the direction of the current. That means minus I1 R2 minus I1 R1. Then which sign of the cell you are seeing? Positive. So you will write plus V1. In this way you are moving. So when you are moving through, you want to measure the potential difference through R3, then I2 is this direction, but you are moving against the direction of the current. That means that will be negative. I2 R3 equal to 0. Okay, that is for A, B, C, D, A loop. And in the loop E, F, B, A, E, you are starting from this point E. Okay, so which sign of the cell you are seeing? Negative sign, minus V2. Then the current is moving. Look, I3 is moving towards this direction, and also you are moving towards the direction of the current to measure the potential difference. So the potential difference through R4 will be what? Positive. That means I3 R4. Okay, then in this way, when you are reaching this point, you are seeing which sign of the cell? Negative. So V1 will be negative. Then the current is moving through this I1 R1 plus I1 R2 equal to 0. So this by these two equations you can solve the circuit. Okay, so here how many variable? R1, R2, R3, R4, these all are unknown to you. So if you want to solve this circuit, then you have to also apply KCL. Let's see a math. Look at the circuit. Here the resistance, here there are, we can see 3 resistance. Here 10 ohm, 1 ohm and 2 ohm, and 2 cells. One is 5 volt and another is 2 volt. And we have to find out the current I1, I2, I3. So you have to remember one thing: where is the maximum battery voltage that runs the main current. So maximum battery voltage is where? Here 5 volt. and here is 2 volt. So main current will be run from this battery source. Okay, so you have to remember always that where there is maximum battery voltage, that runs the main current. So now from here main current is I1. At this point I1 is divided I2 and I3, and we have to find out the value of I1, I2, I3. So here I2 is moving towards this direction and I3 is moving through 10 ohm resistance, I2 is moving through 1 ohm resistance. At this junction at E, these I3 and I2 together forms again the incoming current I1 and comes to this point. So now at the loop A, B, E, F, A, in this loop, that means this in this loop, you start from point A and you are moving clockwise. Okay, so look, I1 is going towards this direction, I3 is going towards this direction, and you are also moving towards the direction of the current. So what will be happen? 10 I3 in loop 1, then plus 2 I1, then which sign of the cell you are seeing? Minus sign. Minus 5 equal to 0. In case of I3, you can write what? Look, I1 is the incoming current and I2 and I3 are the outgoing current. So I3 means what? I3 means I1 minus I2, as I have shown you earlier in case of KCL. Okay, so you can write, in case of I1 you can write I1, sorry, in place of I3 you can write I1 minus I2 plus 2 I1 equal to 5. 10 I1 minus 10 I2 plus 2 I1 equal to 5. That means 12 I1 minus 10 I2 equal to 5. Now if you apply Kirchoffs law in this loop, that means B, C, D, E, again B. That means from where you start, there you reach. So B, C, D, E, B, in this loop if you are applying, here also you are applying Kirchoffs voltage law in clockwise direction. That means I2 is moving this, you are also moving that direction. So here while moving you see the negative sign of the cell, that means minus 2, then current is moving towards this direction and you are also moving towards that direction, so positive 1 I2, then but in this case current is moving this direction and you are going that direction, opposite direction, so it will be minus 10 I3 equal to 0. Again 1 I2 minus 10 I1 minus I2 equal to 0. 1 I2 minus 10 I1 plus 10 I2, oh sorry, here minus 2 volt equal to 2. This minus 2 we can take that side. Okay, so here it will be 11 I2 minus 10 I1 equal to 2. This is equation 1, this is equation 2. Let's solve in the next page. So from the previous page we get two equations, 12 I1 minus 10 I2 equal to 5 and 11 I2 minus 10 I1 equal to 2. Very easily you can solve these two equations. If you multiply equation 1 by 10 and add equation 2 by multiplying 12, then it comes. So from here you can solve the value of I2, you get 2.31. If you put the value of I2 in either of these two equation, you get the value of I1 equal to 2.34 ampere, and you know I3 equal to what? I3 equal to I1 minus I2, so it comes 0.03 ampere. In this way, by applying Kirchoff's current law and Kirchoff's voltage law, you can solve any circuit. Dear students, it is my request to you, you must practice by seeing your book. There is many circuit based problem, so you must solve those, and if you don't understand yet, so you will consult with me. Goodbye everybody.